Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this specific video we will be discussing about data analysis with respect to bivariate part. If you remember in my last video I have covered up about univariate analysis. What is the meaning of univariate? That we are somehow focusing on single variable at a time and we are doing analysis with respect to that aspect. But now our focus shifts towards bivariate. As the name itself suggests, bivariate. Bi means two. Variate means variables. So here what we are focusing now is that if let's say we will be having two variables, obviously in a given data we can have multiple variables. But within, let's take, I will take two variables. I want to compare the performance among those two variables. Maybe by increment of one variable, let's say x, the value of y is also increasing, or the increment of x decrease the value of y, or there is no as such correlation among them. So there can be any possibility, right? So what I want is, I really want to compare the two variables and the correlation among each other, and that is where the need of bivariate analysis comes into picture. Again, it's a really important concept, and to understand this concept, again the foundational concepts of stats definitely is required. So I will try to cover up this specific topic in a very detailed manner in this video. So please make sure that you will watch this specific video till the very end. Might be it would be a long video, but please make sure that if you want to get that better understanding in a crisp manner, you need to have this idea in a very detailed way itself. So please make sure whatever points, whatever topics I am covering up over here, try to document your learning on the way. With this, let's get started. So now I think you get the understanding in the intro part of the video that what is the literal meaning of bivariate analysis. Basically what we are doing over here is we want to examine the relationship between two variables. That's the whole point. I hope that you get that clarity, right? So basically we want to explore the relationship between, I would say, two variables. That's the important thing, or that's the literal meaning of, I would say, bivariate analysis. Now, the next important point is that, okay, we know that what is the literal meaning of that, but the question is, why is that required? Why there is a need in a data analysis task to go ahead with the bivariate analysis? Isn't it that only the univariate one will be enough? The answer is no. It won't be enough. That is why we are jumping towards this bivariate analysis as well. Very important portion, I would say, in the complete cycle of analysis of a given data. Why? Because as I told you, first of all, with the help of this, we will be able to identify the relationship among two variables, right? Or among multiple variables as well, when we will be discussing about multivariate analysis. Second thing is, with the help of this, we will be able to detect the kind of patterns any two variable holds. For example, a few minutes back, I have given you one example that let's say I will be having a one variable x, another variable y. So what is the kind of pattern they hold inherently? Maybe I will observe at the end of the day after doing the analysis that as and when I am increasing the value of x, the value of y is also increasing. Or maybe you will say that as and when I will be increasing the value of x, the value of y is decreasing. It can be anything, right? It can be anything. So basically to detect the pattern or the trend my variables are following, that is easily able to detect with the help of this bivariate analysis. Third and important thing is, let's say you want to uncover the unexpected relationships or the patterns. In that sense also, for the diagnostic purpose, to diagnose something, this specific, I would say, bivariate analysis plays a very huge role, right? Sometimes there are some hidden patterns, there are some hidden, I would say, relationships, or you can say the outliers available in the given data. So in order to detect that unexpected relationships, or in order to examine the outliers, unexpected relationship, or in order to examine the outliers, we can say that this specific bivariate analysis is quite important. Now the question is, okay, it is important. When I am saying with respect to x and y, I hope that you got my point, that for example, let's say I am giving you now the example of this bivariate analysis so that the things will be pretty much clear to everyone. For example, let's say I am analyzing one data, and in that data I am analyzing that any specific kid, how much is the study time he is devoting, and with respect to the value or variable, let's say, how much is the score he is getting in his school. Now let's say we have two variables. One is, let's say, this as x and this as y. So obviously with the given patterns that we will be having, or the given records that we will be having, it might be the case that we will be able to analyze that if a student is devoting higher study time, the score of that student will also be higher as comparable to the one which is devoting lesser study time. By the way, this is quite hypothesis. Sometimes it can happen vice versa as well, depending upon the IQ level of every student. But usually I would say that this is the thing which is happening in a given set of records, where we have observed that as and when the value of x is increasing, means the students are devoting more study time, they will be able to achieve the higher score. So basically we will be, if let's say I want to analyze these two variables simultaneously, then obviously I have to go with the bivariate analysis. Now whenever we are talking about this bivariate analysis, there can be three categories via which we can do the analysis. First category will be, now these categories depends upon what kind of data you have. I hope you all know that whenever we are dealing with any kind of data, usually we have two types of data points. Either the data points will be continuous, or they can be categorical. Continuous means that we will be having some numeric numbers available in that specific part, and categorical means that we are having some sort of categories or classes available in that data, right? So one type will be where your both the variables are continuous. So you will say that the first type will be continuous and continuous. It means that whatever be the x and y I'm talking about, they both are having a continuous values available with them. Second type of bivariate analysis will be where one variable can have a categorical data, whereas another variable can have a continuous data. Okay, so one variable can have a categorical data, another one is having a continuous data. And the last and important thing will be where both the variables can have categorical and categorical data. So for both the variables, we will be having a categorical values available in a given data points. Now, when I'm saying that both the variables x and y belongs to continuous entity, the metric will get changed. So that is where we have something called as correlation coefficient for the plotting per se, to examine that how much they are correlated. Or we can have something called as scatter plot as well, to do the visualization, to examine the plots, to do the data analysis part per se. So with the help of this, we will be able to examine the relationship amongst two variables that we will be having. If let's say you are saying that in one part I will be having a categorical data, in other part I will be having continuous data. So this is where the best way to do the plotting is box plot, right? I will showcase you, don't worry, each and every example practically in this session. But obviously, just to illustrate you, I hope that you all understand when I'm saying continuous and when I'm saying categorical. For example, if let's say I will talk about this specific data that I will be having. So here, let's say I'm having Marshall, in the last video also I have named it wrongly, marital status. So when I'm saying marital status, the example could be that either the person will be single or that person will be married. So there can be two classes, right? Maybe there can be other classes as well. But for now, let's consider this only, that with respect to this specific field, we have two classes, either married or single. So this is something which we can say it as a categorical data. Second thing, when I'm saying continuous means, for example, income. Income is a very best example where we can say that, okay, on a monthly basis, how much that person is earning, whatever be the records we will be having. So this is how basically we are categorizing our data points into two types, categorical and continuous. So for continuous, we have a different spirit of doing the analysis. For categorical, we have a different spirit. So when I'm saying bivariate means those two variables can be continuous and continuous. Those two variables can be categorical and continuous, and those two variables can be categorical and categorical. Depending upon that, our way of doing the data analysis will be different. That is why I'm saying when we will be having continuous and continuous, correlation coefficient or scatter plot is a good way to approach. When we will be having a categorical and continuous entity, box plot may be a good way to analyze the data. And when we are having a categorical and categorical, in that sense, the frequency plot, which we usually create with the help of pivot tables and pivot charts, that might be a better idea to plot. Now, how can we do that? How is this feasible? Let's try to go ahead and discuss this step by step. Let's say the very first easier example is categorical and categorical, right? Categorical and categorical bivariate analysis. What is the meaning of that? For example, let's say we are having two fields or two variables available with us. One variable says that whether a person will be having a lung disease or not. Okay, whether the person will be having a lung disease or not. So in this case, the person can either have or that person don't have. Second variable that we will be having is that whether the person smoked or ever having a smoking habit or not, or maybe you can say person's smoking status. So now again, it is also having maybe three categories. This is one field that we will be having X variable. Y variable says smoking status. There can be three categories for the same. Maybe the person never smoked. Maybe we can say that the person is a former smoker. Maybe we can say that the person is a current smoker. So we will be having three categories. Now it might be the case that any person who is the former smoker or is the current smoker have a higher chance of getting a lung disease as comparable to the person who never smoked. But there might be a few exceptions where the person never smoked, but still they will be having a lung disease. So basically, in this specific case, if let's say I want to analyze this kind of data where I have both the fields which are categorical, right? Where in both the variables we will be having a classes available with us. That is where we will try to create a frequency plot. That is where we will try to create a frequency plot. How can we create that? Obviously, you can create a pivot table, and then with the help of those numbers, you will be able to analyze that what is the kind of relationship it holds, whether there is any direct correlation between lung disease and smoking status, or there is no correlation at all. I hope it makes sense to everyone, right? For example, in this specific example which we will be having, let's say, two data points. One is marital status, another one is, let's say, gender. Both of them belongs to a categorical data. marital status can be single or married, gender can be male or female. If let's say I want to analyze these two fields, so maybe what I can do is I can create a pivot table in a new worksheet, and once I will create that, oh, it just created for a marital status. I don't want to create like this. Let me just delete this completely, and I'll not select anything so that it won't take only the one column. I want it to take the complete entire table itself. So now I think it is taking a complete table, and now I have all the fields available. Now if let's say I will pick up the marital status in the rows, and let's say I'm picking up the gender as well. So maybe I want to analyze with respect to married, what is the count of gender? With respect to single, what is the count of gender? Or maybe we can take it as a filter, and I want to analyze with respect to females. Let's say what is maybe the count of gender with respect to female, and with respect to male, what is the count of gender? So basically what you are observing over here is you are trying to analyze the performance of marital status with respect to the I would say gender. Maybe there are more female who are inclined towards single as comparable to getting married. Whatever be the analysis is, it all depends on what kind of business problem you're trying to solve. But I hope that you get my point, that whenever we will be dealing with two categorical data entries, that is where the best way to approach this kind of analysis is to create a pivot table, and after which, depending upon the business use case, we will be able to see that what things we can put as a filter, what things we can put as a row, what things we can put as a value count, and accordingly we can solve that problem statement, right? Second specific thing is categorical and continuous, right? Now, what is the best example of categorical and continuous, which is the second variety of analysis which we can do as a bivariate one? For example, let's say you want to analyze with respect to a given age bracket the income of every household member. Maybe you want to observe that which specific age bracket is earning more, right? Now, when I'm saying one specific age, that will be a continuous number. But as soon as I am talking about age bracket, that will be a category. Maybe I'm saying that first of all, let's say 20 to 30, then 30 to 40, 40 to 50. So this will become the class now. This will become a category now. Maybe we will be able to get the analysis that the people who are belonging from 21 to 30 age, let's say they are earning maybe on an average 1 lakh on a monthly basis. The people who are having a age from 31 to 40, they are earning, let's say, 1.5 lakh. And the people who are earning within the specific range from 41 to 50, let's say they will be having a salary of 2 lakh. It's kind of assumptions that we have made. So we are saying that the people who are earning, who are having a higher age might be earning more in a given data set. So here also we will be having a age column as well as income column. So let's try to see, for example, if let's say I will put age in the rows, and what I will do is with respect to this age, the better idea could be that we will try to apply some sort of grouping over here if possible. So let's try to do one thing. Let's try to do a group, and here we can say yes, by 10 I think we can do a grouping very easily. So starting number is 25 we can see in this given data, ending at 89 by 10. So just simple right click on the group, and let's click on this OK. Now you can see as soon as I will do this, initially I was having just single entities 25, 35, 40 and so on. I have made a group, means I have converted this entity into a part of a group. And now I will put, let's say, the values internally as so by default it is showcasing me the count of income, but I don't want the count. So I want to summarize, maybe let's say further values, the average income, let's say. Oh, so this is not good. Let's try to see any other field. So it is giving me a count of the people who are earning between this specific age, between this specific age, between this specific age, and so on. So one thing which we can analyze from this specific use case is that the people who are in the age range from 35 to 44 might be in a state to earn more as comparable to the people who are in other age brackets. 25 to 34 is at third rank and 45 to 54 is at second rank. The people who are in the age range from 85 to 94, it's quite old age. That's quite rare that still that person is still earning. A single person belongs to that specific field. But the thing is, I won't be able to summarize the value with respect to other specific entries like sum or average, which gives me a much better idea. I know the reason why is that so, because this income is something is in the form of a dollar. So if somehow we can format this cell and convert it in the form of, let's say, number, that might work with us. But for now, I'm just thinking that whether I should change the given data or not. So that is the whole thing. We can try. So maybe we can format the cell, number, currency, accounting, date, time, percentage, this. No, number is fine. But still we have dollar symbol with us. That is something which we need to take care of. Let me refresh it again. And let me try to do no. So basically we need to avoid that dollar symbol so that we will be able to get the values in the form of average. Otherwise it will throw some error. So we can do that as well by using that find and replace symbol, and we can just replace this dollar symbol with the empty space. But for now, let me not edit these entries because might be I required the same exact entries in the near future. So that is the main reason I'm not doing so. But I hope that you get the idea that what I'm trying to convey over here, simple thing I want to convey. The point is that at any point of time, if let's say I want to analyze the specific age entries. So now I have converted it into how many categories we have? 1, 2, 3, 4, 5, 6, 7. So we have 7 categories, and with respect to that, I want to see that, let's say, the average income, and maybe I got that the people who are in the age bracket of 35 to 44, because their count is more, might be their average income is also more. Maybe I will share this data with you all. You can just try to work upon it by removing this dollar symbol with empty space and then convert it into a numeric data. Then things will work definitely fine. I'm pretty sure. Then you will be able to summarize these values very clearly by sum as well as the average. Average will make a more sense as comparable to doing a sum. So with the help of this, you can easily work on it, right? With the help of this, you can easily work on it. Also, we will be having age bracket field as well. Oh, that is also amazing. So we can see that the people who are in this adolescent age, the count is quite less. Middle age, the count is quite more, which makes sense as well. Old age, the count is again quite less, but not less than the adolescent. So last is adolescent phase. The top one is the middle age, middle one is the old age. So this is how basically we can do the analysis with respect to categorical and continuous data. With respect to this specific data points, where one field we will be having is a categorical part. Another field, or I would say another column that we will be having is a count of income. We can easily do a plotting on top of that. So what kind of plot can we create over here so that we can look inside the insert part. I think we can go ahead with the charts visualization. As soon as you will enter into the more scatter plot charts, you will be able to observe that we have several options to create that. For example, let's say I will try to create a column chart. Quite simple, but again looks very intuitive. You can clearly able to observe over here that the middle age is somehow having a higher count of income as comparable to the adolescent as well as the older age number, which makes a lot of sense as well, right? So this is how basically we can do the visualization part on top of whatever with the frequency numbers which we have plotted in the left hand side. One thing which you also agree with me, that whenever we are observing anything with respect to the given numeric data versus if someone will give me a plot for the same, we will always appreciate that visualization thing, because somehow in our brain that easily gets captured as comparable to the numbers that we will be having. So the same thing we will be having over here as well. So the main purpose of this session is to give you an intuitive idea that why this visualizations are pretty much important and how can we create that. That's the whole objective of today's session, right? Now coming to the next important point. Till so far, whatever we have covered up is with respect to the categorical and continuous data, where in one part of the column we will be having a categorical class. In other part of the column we will be having the continuous numbers. Now the third thing which we will discuss today, again it's a part of a bivariate analysis, and if you will be able to observe, the third component which is still left is about continuous and continuous. What is the meaning of this? The simple meaning is that, in other words, we will be having both the fields as the continuous fields, right? We will be having both the fields as continuous fields. What is the meaning of that? You can take several examples to illustrate the similar concept, but I will try to give you a few over here. With respect to the given data that we are dealing with, maybe you can take with respect to, in this specific case, maybe we will be having income as one part and maybe age as another part, right? Or you can say, I think remaining columns are exactly the categories that we will be having. So for now, consider that you will be having, with respect to every specific age number that we will be having, the corresponding income of that person. So now when I am taking a simple age specific data point, it's a continuous number. But as soon as I will do the grouping, just like the way I have done in the previous part of our discussion, that will become the category. Even though the column is same, but still the values will get changed, the classes will get changed. I hope I'm making sense over here, right? So now in one column we will be having a continuous data. In other column also we will be having a continuous data. This is again a very amazing topic to discuss, and how can we do the, I would say, data analysis on top of this, right? Now there can be again multiple ways to do the analysis, but the common practice is to go ahead with the correlation coefficient. The common practice is to go ahead with the correlation coefficient. Now, what is the meaning of this correlation coefficient? If you will see the mathematical intuition behind the same, there is an appropriate way to evaluate this, just like the way we used to evaluate variance, standard deviation in the concepts of statistics. But today I am not going into that specific part. I just want to give you a layman term idea behind this correlation coefficient. So if, let's say, you will be having two variables, maybe the two variables are x and y. The two variables are x and y. These two variables are somehow the features of my data, feature f1, feature f2. Now when you are saying correlation coefficient, this is a value which lies from -1 to +1. Now this value can lie from negative extreme 1 to positive extreme 1. Now, there is always a magnitude which we usually measure in this correlation coefficient, and with the help of this magnitude of correlation coefficient term, we will try to understand that whether the two variables features f1 and f2 are highly correlated, moderately correlated, or not at all correlated. For example, let's say if you will be having any specific I would say correlation coefficient value among this specific range, you will call that correlation coefficient as very weak. You will call that correlation coefficient as, I would say, very weak. Very weak. After this, if let's say you will be having a magnitude of correlation coefficient from 0.20 to 0.39, you will call this as weak. If you will be having a correlation coefficient among 0.40 to 0.59, you will call that as a moderate value of correlation coefficient. After this, we will be having from 0.60 to 0.79, we will call it as a strong. 0.80 to 1.00, we will call it as very strong. So in this specific sense, you will be easily able to observe that as per this specific magnitude, either the correlation coefficient value will be very weak, or it will be moderate, or it will be very strong, depending upon what is the magnitude with which we are trying to evaluate this term. Now, what is the understanding behind these two values, whether it is negative or positive? If let's say you are saying that by increasing the feature f1 value or the x value, the value of y is also increasing. It simply indicates that those two features are positively correlated. It means that those two features are positively correlated. For example, if let's say I am saying that the study time of any student and score, if let's suppose that I am trying to evaluate these two features, and what I have observed that if any student is having a higher study time, somehow their score is also increasing. Maybe because their focus is now on specifically studies and they are trying to maintain their discipline, hard work they are doing on top of it. So that is the main reason, I would say. So if we will try to evaluate the correlation coefficient among these two features, feature f1 is the study time, feature f2 is the score. What we are observing over here, these two features are somehow positively correlated. I hope it makes sense to everyone, right? But on the other hand, now how much they are correlated, that is where the magnitude and the strength with respect to very weak, moderate or strong will come into picture. Now on the other hand, if let's say I will say playtime is one feature and again score is another feature, or maybe you can say nowadays we have another amazing thing, reels watching time, right, which no one usually observes, but if we will be able to see, many students are spending their lot of time on watching the reels as well. So if let's say we are trying to observe these two features, where one feature is that how much time they are spending maybe on Instagram to just watch the reels. So what we are observing, that as soon as the reels watching time is increasing, their score is decreasing. So kind of there is an inversely proportional ratio with respect to the reels watching time and the score, and that is where we will call this kind of result where one variable is increasing and with respect to that other variable is decreasing. This is what we called as that they are negatively correlated. They are negatively correlated. It's very important. It's very important aspect. So both of them, whether we are talking about this specific aspect or we are talking about this specific aspect, both of them are having an interconnection. Both of them are correlated, but one specific feature you can say is a positive correlated, another one is negatively correlated. So I hope that you get the point. What is the meaning of positive? If one is increasing, other one is also increasing. What is the meaning of negative? One is increasing, the other one is decreasing. Now, how can we evaluate this specific value of correlation coefficient in the Excel? We will cover up that for our analysis. But before that, I hope that this part is pretty much clear to everyone intuitively. If let's say you have the features in which you are saying that these two features are not at all correlated, not at all correlated. For example, let's say you will be having one feature X, which is maybe their wake up time, like at which specific time they usually wake up in the morning. And there is another feature we have, which is Y, again a score. Now I don't really believe that whether these two features, that at what time that particular student is waking up, maybe they can stay late at night studying all the way around and they are waking up very late. It might be the case, it might be the scenario. So we cannot somehow correlate these two features, right? So in this specific sense, because these two features are not at all correlated, we can say that their correlation coefficient value will be 0. So always remember that when the two features X and Y, they are not connected with each other. So in that specific sense, we will always say that the correlation coefficient value will always be equals to 0. So that is the important thing which you have to understand. Now, how can we evaluate this topic of correlation coefficient that we have covered up just now? So for that, what we can do over here, maybe we can take the two values. Let me try to build one scenario for this specific aspect. So in this case, we will be having in one of the data the minimum fruits, and in other data we will be having minimum sweet products. So let's try to see that how these two arrays that we will be having, the fruits column and the sweet products column, how they are interconnected with each other. Again, if you will be able to observe this very carefully, these two are the continuous values, right? So if let's say I want to see what is the correlation value among array 1, which is minimum fruits, comma, array 2, which is minimum sweet products. So you will be able to see that I am getting this number called as 0.56. Now this is what we call this value as correlation coefficient. This is what we call this value as correlation coefficient. Now if you will try to see this value very, very carefully in this specific aspect, if we will go back again to our editor where I have written this down, you have seen that we are getting the value in the range from 0.40 to 0.59. It means that somehow this specific features which we have talked about, the minimum fruits and the minimum sweet products, they both are somehow positively correlated. And what is the strength for the same? We can say it will be somehow a moderate correlation among these two features. Similarly, you can try at your end what is the correlation coefficient value among number of web purchase with respect to number of store purchase, right? So what we will do over here, so you can again try to see what is the correlation coefficient value among number of web purchase followed by number of store purchase. So as soon as you will do this, again you can easily able to get the correlation coefficient value for the same. Now the above thing which we have done the evaluation, this is with respect to the minimum amount of fruits followed by minimum amount of sweet products. But in the second direction, what we are observing is the correlation coefficient among number of web purchase and number of store purchase. So with the help of this, you will be easily able to get the idea intuitively that whether these two features are highly correlated, moderately correlated, or weakly correlated, right? So this is the overall part of doing the continuous, I would say, analysis. So this is basically overall idea with respect to what I'm trying to cover up over here. Apart from this, obviously, if you will be having a two continuous features, just like the way we have discussed in the number of web purchases and the number of store purchases, the better idea could be to go ahead and do a scatter plot. I hope you all know that how can we do a scatter plot. This is a kind of a scatter plot which you can see on my screen as well. It's just that we have many features, that's why it is looking very clumsy. But if let's say you will be having only two features, maybe let's say you are working with these two features, I'm just copying it up and pasting it in the next screen. So here you can see that if let's say I want to try to do the visualization for these two continuous features, so you can clearly observe over here, maybe this doesn't look much better. So so here just give me a moment. I think I need to reopen it again. Oh, okay. So if you can see over here, this doesn't look much apt to me. Maybe instead of this, what we can do is we can again go to the insert part and try some other sort of scatter plot over here. I think there is some. So let me select this completely and now do the insertion with respect to the plotting part. Or what else? So you can try and explore that how these kind of plots will look like, and accordingly you can check it out that whatever plot will give a more intuitive sense, you can easily able to check that out, right? For example, in this specific case, although this plot is not looking great to me, but it gives one intuitive idea to me that a lot of data points are lying among 0 to 10 specific range. And then because this is a kind of a dense area, which we can see clearly over here, and after that 10 to 30 or 25, 28, it's kind of a rarest data points which lies among that specific range. But I feel still we can create much better plot for the same. But usually if I will try to give you an idea, you can have a look whenever you are doing any kind of analysis in terms of continuous numbers. Foremost thing is the correlation coefficient. Always have a look onto that. I have showcased that how can we do that. So one thing is the correlation coefficient, and what is the purpose for the same we already have discussed. Another thing is go ahead and try to do a plotting with respect to scatter plot. Scatter plot will always tries to give us the relationship among two features, that how the two features are interconnected with each other, and that is where I would say that this is again much better. But again, it depends on which specific fields you are working with. For example, currently the fields that I have showcased you, scatter plot doesn't look that much apt to me, but definitely it really depends on what kind of data set you are working with, and might be scatter plot is one of the interesting plot in that specific scenario. So this is the overall idea behind the bivariate analysis. I hope that you get the point that to understand that how the two variables are interconnected with each other, we have three different ways depending upon what kind of data we are dealing with. Continuous and continuous, categorical and continuous, and at the very end we have categorical and categorical. So all of them I have covered up in a lot more detail. After this, we will be having multivariate analysis as well. What is the meaning of multivariate? Where, let's say, you will be having a more complex data, and at one point of time, you want to deal with multiple variables. You want to see the pattern of multiple variables. That is where multivariate analysis comes into picture. So, I think whatever concepts we have explored till so far, I hope that this much is pretty much clear to everyone. We will cover up further details with respect to this specific topic in the upcoming session. With this, bye bye everyone, and I'll see you all in the upcoming videos.